So there is a problem in PDF, right? Okay, we will see. Right. So what is the mechanism to determine the given sequence of functions are uniform, convergent or not? So we have a variety of methods to determine the given sequence of functions, whether it is uniformly convergent or not, right? So we will see one by one. So we know that first one, if Fn is a sequence of continuous function, converges pointwise to a function f. So what is the condition of this one? The condition is each function is a continuous. If the sequence is converges pointwise and the limit function is also continuous, so there is a guarantee to say that convergence, that pointwise convergence is uniformly convergent. So that is one of the theorem what we discussed. That is also I told in class, that is an important theorem, right? So first we will see the tutorial sheet number 1 problem. That is the given function fn from closed interval 0, comma 2 to R defined by fn of x is equals to 1 minus 1 over 8 times x cube to the power of n times e to the power of 2x for all x belongs to 0, comma 2. So keep in your mind, once it is a closed interval, first you have to find what is that convergence at x is equals to 0, right? And x is equals to 2 endpoints and then in between, right? So first we will see at the endpoints. So at x is equals to 0, fn of 0 is equals to 1 minus 1 over 8 times 0 to the power of n e to the power of 0, right? So that is equals to 1 to the power of n. Of course, e to the power of 0 is equals to 1. That is equals to 1. So what happened? Fn of 0 tends to 1 as n tends to infinity, right? Number 1. So what about at x is equals to 2? We have to calculate Fn of 2 is equals to 1 minus 1 by 8 times x cube, that is a 2 cube, times e to the power of 2 times 2, that is 1 minus, this is 8 by 8, that is 1 by 8 times 8, that is 8, 8 cancel, that is e to the power of 4, but this is equals to 0. So therefore, Fn of 2 tends to 0 as n tends to infinity, right? So that is right. So what about the values of x lies in between 0 to 2? So then we have to calculate what is your function. Generally, your function is Fn of x is equals to 1 minus x cube by 8 to the power of n e to the power of, right, um, x square, right? That is your function. Yeah, e to the power of 2x. So now you have to verify what is this value when the value is x in between 0 to 2, right? So come on, tell me. So what about 0 is less than 1 over 8 times x cube? Because your x is a member of 0 and 2. That is nothing but a 1, right? So of course, if it is more than 1, that is 8 cancel, you will get less than or equals to, you can say 1, right? So what happened? I am going to subtract on both sides, or I can, what I am going to do? So 0 is less than 1 by 8 times x cube, right? That is less than 1. So now what happened? I will multiply with minus, that is minus 1 is less than minus 1 by 8 x cube is less than 1, because in our problem this is 1 minus x cube, right? So now I am going to adding 1 on both sides, entire the inequality. That implies 1 minus 1, 0 is less than 1 minus 8 over x cube is less than 1 plus 1, that is a 2, right? So then what is the value? Okay, that is 2. 0 is less than 1 minus 1 over 8 times x cube, right? This is, I think there is a minus 1 here, right? When we are multiplying with the minus 1 is there. This is a 0, right? So this is 1. You catch my point? So this one, when I am multiplying with the negative, what happened? Minus 1, the inequality will be changed. Minus 1 is less than minus 1 over 8 times x cube is less than 0, right? Now I am adding 1 on both sides. So that implies 0 is less than 1 minus 1 over 8 x cube is less than 1. So what I am going to, I am increasing power n, enter this one, that is 0 is less than 1 minus 1 over 8 x cube to the power of n is less than 1 to the power of n, right? Isn't it? So 1 to the power of n is equals to 1. What is this value? That value is approaches to 0 as n tends to infinity. So therefore, what is your fn of x? Fn of x is equals to 1 minus 1 over 8 times x cube to the power of n e to the power of 2x. This tends to 0 as n tends to infinity. So what happened in the Right. So what we got here, the Fn of x is equals to limit n tends to infinity is equals to 0 if x is equals to 0 to what is the value at x is equals to 2, that is at x is equals to 0, this is equals to 1, right? And the remaining value, if 0 is less than x is less than or equals to 2. So this is your function f of x. So f of x is equals to 1, that is when x is equals to 0. If x lies in between 0 and 2, that is a 0. What is this function? Is it continuous function? That is f of x is equals to 1. If x is equals to 0, 0, if 0 is less than x is less than or equals to. So clearly the function is discontinued at the point 0. But what is your fn? Fn of x is equals to 1 minus 1 over 8 times x cube to the power of n. This is a polynomial times exponential function, that is e to the power of x to x, is also a continuous. The product is also continuous. So therefore, Fn is continuous for each n. So Fn is continuous for each n, right? Then your limit function f is not a continuous. So according to the theorem, we can conclude that the convergence is not uniform, right? Isn't it? So what happened? Uniformly convergent implies point-wise convergent, but point-wise convergent need not be a uniformly convergent. So if you want to say this one is a uniformly convergent, then the limit function is also continuous, right? So that is to determine whether the given function is uniformly convergent or not, right? What about the second model by using the MN test, right? So what is the MN test? So for example, my Fn is a function from 0 comma 3 to r by Fn of x. Fn of x is equals to n plus x square over n square plus 2n minus 2 plus x for all x belongs to 0 comma 3. Here is interval open interval. So no need to verifying the endpoints. The endpoints when we are, so it is a closed interval, right? Or one of the side may be a closed. Okay, so we can verify by using the MN test. What is the first we need to verify whether it is a point-wise convergent or not. So everyone knows this one. This is a limit n tends to infinity. Fn of x is equals to, you can divide, the highest power is n square. So you can divide by n square on both sides. N by n square plus x square by n square over, of course, you will also put the limit n tends to infinity. Here n square by n square plus 2n over n square minus 2 by n square plus x. So what happened, that is limit n tends to infinity. You will get here is 1 by n plus x square by n square over again limit n tends to infinity properties of the limits. We will get 1 plus 2 over n minus 2 over n square plus x by n square. What happened? All these values are approaches to 0. So actually 0 by 1, that is equals to 0, right? So what about this one? We can say that one, the given function fn tends to f, where f is a 0 function, pointwise on the interval 0, comma 3. Now we are going to verify whether this convergence is uniformly or not. That is, we are going to utilize the MN test. What is the MN test? For each n belongs to n, we need to calculate what is the Mn. Mn is equals to, right? That is supremum of modulus of Fn of x minus f of x, right? Where supremum is taken over all values of x belongs to 0, comma 3, right? So what is this one? This is a supremum of modulus of Fn of x is n square, sorry, n plus x square over n square plus 2n minus 2 plus x minus 0, because this is your f of x, because here is your f of x is equals to 0 for all x belongs to this one. So what happened here is, so you have to look this denominator. What is the denominator? N square plus 2n minus 2 plus x, where x is the 0 is a member of 3, right? So we know that we can't substitute directly here in the denominator. So denominator we need to reduce without x, right? By using some inequality techniques, right? So we know that n square plus 2n minus 2, right? Okay. What we are going to do, this value is greater than n square. Is it correct or not? N square plus 2n minus 2. Is it greater than n square or not? Yeah, put n is equals to 1. Then you will get 2n minus 2, that is equals to 1. You can say greater than or equals to, right? N square plus 2n minus 2 is greater than or equals to n square. Hello, are you hearing? No one is responding.
Yes, sir, yeah.
Yeah, so this is greater than or equals to n square. That implies n square plus 2n minus 2 plus x is greater than or equals to n square plus x. So this implies this value is greater than, but 1 over n square plus 2n minus 2 plus x is less than or equals to 1 over n square plus x, right? So now I am replacing the denominator, this one by, I am going to put n square plus x. So that is supremum of modulus of n plus x square over n square plus x, where x belongs to 0 comma 3, right? Again, we need to reduce the x, isn't it? What is the x? X is greater than 0, right? Because your x belongs to 0 comma 3. So that's why x is greater than 0. So what is the n square plus x is greater than n square, right? So what happened? This implies 1 over n square plus x square is less than 1 over n square. Again, I need to reduce that one is, what is this one? I need to reduce this one by supremum of x belongs to 0 comma 3 modulus of n plus x square over n square. So here is n, here is n square, here is x square. So x square is increasing function. So what is the supremum? Supremum is the right hand point. So that is, you can put in place of x is equals to 3, that is equals to 3 square is 9, because x square is increasing function. So now what is your supremum of all this value is equals to or less than n square plus 9 over, sorry, n of n plus 9 over n square, right? So what happened? Your mn, this is your mn, right? Your mn is lies in between, mn is less than n plus 9 over n square, right? What happened? The right hand side, this tends to 0 as n tends to infinity. By sandwich squeeze theorem, your mn tends to 0 as n tends to infinity, right? So once your mn tends to 0 as n tends to infinity, by mn test, your sequence of functions converges uniformly, right, to a function f that is nothing but 0 function on the interval 0 comma 3, right? So this is by using and checking how do we get the supremum such a way. So right. Okay. So what is the next problem? The same that one. This is Fn from 0 comma 1 left to open right close to R defined by Fn of x is equals to 3 to the 3n to the power of 4 plus n times cos hyperbolic function hx over 2n plus n to the power of 4 times x to the power of 4 plus sine square of x for all x belongs to 0, 1. Right? So we know that this is by using what is here. It is to verification of the bounded function, right? Okay. So first we will check whether this function is bounded or not, right? What is here? What I am going to verify the theorem. Each Fn is bounded and two Fn is pointwise convergence to a function. Yeah. If F is bounded, then your convergence, right? Your convergence, that is pointwise, is uniformly convergent. If the limit function F is not bounded, then it is not uniformly convergent, right? So all these are indirectly what we proved the theorems. Uh, we call these are the testing for the uniformly convergent, right? Okay, so right. So you have to see the what is the convergence limit function. So first verify the uh, function is whether it is a bounded or not. Each Fn is a bounded or not. So verify modulus of Fn of x. If it is less than or equals to some m or mn, that is each function is bounded, right? So let us say modulus of Fn of x, that is 3n square plus n cos h of x over 2n plus n to the power of 4 times x to the power of 4 plus sine square of x, right? So you know that the denominator, this is since 2n plus n to the power of 4 times x to the power of 4 plus sine square x is greater than or equals to 1, and 1 over 2n plus n to the power of 4 times x to the power of 4 plus sine square x, right, is less than 1 by n, right? Of course, you can make it a n, right? So you can up to this one is greater than 1 and adding 1 plus or both sides. If you adding a 1 plus 2n and again 1 plus 2n is a greater than 2n. So totally the denominator is less than 1 by 2n. So just we need to try to make a least value. In this one, n to the power of 4, it is a 2n is there. So we try to reduce the least power of the n. So here least power of n is to the power is 1. So we try to reduce all these terms because all these values are greater than 1. So we can reduce 1 by 2 to the power of n. So that is the related to the inequality. So what happened? The entire this value is a less than or equals to modulus of 3 to the power of 3 times n to the power of 4 plus n cos hx hyperbolic function over 2n, isn't it? So you can take out 1 by 2, that is 1 over 2, right? So that is 3 n cube plus you can put which is less than or equals to cos hx, because the values of x belongs to 0, comma 1. So you can put that is a cos h of 1 hyperbolic function. So this is your MA. So modulus of Fn of x is less than or equals to 1 by 2 times, right? 3n square plus cos h of n. So F1 root n is equals to 1. So that is a bounded function. So each n, Fn is bounded. So now what we are going to do, what is the f of x? So now what we concluded, each Fn is bounded. So what is the limit function, whether it is a bounded or not? So limit n tends to infinity, right? Fn is equals to limit n tends to infinity. This is your simple way, right? So that is 2n plus n to the power of 4 plus x to the power of 4 plus sine square x. So divide by n to the power of 4. Right? So every term will be, here is a 1, every term is 0, this is a 0, right? But here is n to the power of 4, n to the power of 4, this is also a 0. So finally we will get this value is 3 over x to the power of 4. This is your f of x for all x belongs to 0, comma 1. Now my question is whether this function is a bounded or not. Of course, when we are seeing this one f of x as x approaches to 0, that is very smallest value, this will going to bigger one. Okay, how do we show that one? Actually, we can say that function f is not bounded. So hence the sequence is not uniformly convergent, right? So we will verify with the formal way, because if f of x is a bounded, if f of x is a bounded, we have to show that there exists m greater than 0, such that modulus of f of x is less than or equals to f. So now I am going to take, right, uh, 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 I am going to take for all m greater than 0, contrapositive statement. So modulus of f of x is greater than m, then f is not bounded, right? So now I am going to choose x is equals to 3 over 3 plus m to the power of 1 by 4. Then you can verify modulus of f of x, right, is equals to 3 over 3 plus m, that is equals to 3 cancel, we will get 3 plus m, which is greater than. So modulus of f of x is greater than m. So that implies f is not bounded. Even this is also a true f of, but showing that f is not bounded, this is a formal approach. You can also say here, as x approaches to 0, f is unbounded. You can also write in that way, right? So this is the another technique, and also uh, there is another problem which is the same. By using the MN test, you can verify accordingly, right? And in the same way, the series of functions, right? So whether the series of functions are uniformly convergent or not. So in tutorial sheet, there are four problems. So, but in the series of functions, we are using the Weierstrass M test, right? So I don't know. So everyone is, I expect to grasping this one, right? Any doubt up to this point?
No, sir. Okay.
Okay. So what is the, I may ask the question, how do we go to verify whether sequence of function uniformly convergent or not? You can also use the bounded test or continuous test or integral test or MN test, whatever we discussed in, you can use any one, right? Which one is an appropriate? If I am asking a particularly, so you can use that one. If I am asking determine whether it is uniformly convergent or not, that is choice is up to you, right? So where you are perfect, you can do according, right? So what about in series of functions? The problem is, okay, I need to stop the recording.